So just draw any random trapezium.
Random trapezium. All right. Okay.
Okay. My claim is that the line segment joining the midpoint of the parallel sides.
Line segment joining the midpoint of the
parallel side.
Okay.
And the diagonals are concurrent.
And the diagonal.
The other diagonal will pass through the.
My God. Okay. This is the midpoint.
Yeah. How do we prove this?
Okay. Wait. Line.
Yeah, basically my laptop is still loading, so I'm joining from my phone. I am going to join from my laptop number.
Okay.
So I asked.
Okay. So the claim is that in any trapezium, so if we have A, B, C, D, and this is midpoint E, midpoint F. So AE equal to EB, and DF is equal to FC. Given this, AC, BD, and EF are concurrent. Okay. Concurrent means they all meet at some point, right? Yeah, I've not done a very good job, but
yeah, correct. Yes.
Okay. So I'm looking at this. I'm wondering. Okay, midpoints of the other two lines, it will not work. So only the midpoints of the parallel lines for which this will work.
Yeah. Yes. Correct.
Okay, I want to test it with this. Okay, so it works with this as well.
Like, do we start with finding angles, or how is it, like starting from angles, or how do we start?
So one way that I can think of is we can show that these 3 points are collinear, right? We need to show that EF, and let's call this O, not O, let me call this G. So we need to show that E, G, F are collinear. This is one way I'm thinking. I don't have any other approaches yet. So to prove that they are collinear, we can try in different ways. Either we can show that EF, length of EF will be exactly EG plus DF, or we can show area of triangle EFG is 0. All these would show that as collinear.
Like why I asked the angle is like that at the point of at the point O, if we show that they're all those angles which are vertically opposite are equal, then the point O is where's the meeting point of all the lines. I mean, I don't know. Can we take like that?
Can you repeat what you said?
So at the point O, if you take any two vertically opposite angles, if we prove now let's not call it as vertically opposite. Now let's just take it as opposite angles, which will turn out to be equal.
Nice. Yeah. So you can look at any one diagonal and this line EF, and if we show that these opposite angles are turning out to be equal, that's
why they are meeting at.
Very nice. Very nice.
Can we think about the proportion at which, for example, the two diagonals A, C, B, D and EF, how are at the point O, are they getting cut at the same proportion? That is AG to GC. Is it the same as EG to GF and BG to GD? I'm just thinking out aloud. I'm not sure, but
So
will that
visually in this diagram, I can see that it's not the case. Like ratio, no?
ratio?
Okay.
Oh,
Lengths are definitely not the same, but is the ratio the same?
ratio. I'm talking about the ratio, not the length.
Nice question. That's also something we can explore. So are the proportions the same?
Yes, I think it will be same. We can show that.
Another thought process with respect to the similarity of the triangles that they
Right.
make.
Right.
I think has it been already discussed?
No.
Similar triangle AGE, is it similar to triangle how do I put it, CFG? AGE, am I
What is the symbol
sorry
for
not
similar?
AGE, is it similar to CGF?
CGF.
Similarly, triangle
Wait, one
EG,
sec. What is the symbol for similarity? I forgot.
similarity is just wavy line.
This?
It's just the tilde.
Yeah,
just
only once.
Okay.
EGE similar to CGF, and another one, both of them include the midpoint line which is joining the midpoint. The other thing is triangle EGB similar to AGD, FGD, sorry. EGB
So
to
EGB.
FGB to FGD.
Right. So these two.
So again, I think the proportionality concept will also be established if you are able to prove
The collinearity of.
So I have an objection with the previous thought process. That is like saying angle EGF is 180 or also this. So Soumya, how are you defining the point G? Are you taking it as the intersection point of the diagonal?
that's it. I am just taking it as an intersection point, considering I do understand that we have not established that it is going to be the same intersection point for all the three lines.
Correct.
That is something that we need to prove at the end of the day.
So if all the three lines are concurrent, then we have, then we can say that this angle EGF makes sense. But if we haven't proved it will actually be some small triangle. So it is like, no, it is just one point.
Right.
Or all the angles around that point, is it adding up to 360? If that, then it is collinear. Can we say?
Which angle?
I mean, all the angles around that point, let's say G, angle AGE plus EGB plus BGC plus FGC plus
that would
FGD.
Be two. Oh, okay.
But that would be true anyway.
Only if not. Can that be a converse to collinearity? That's what I'm trying to understand.
No. So the thing is, even if EG and GF, that is, they are not straight lines, that statement will still be true, right?
So, but that is not
why
under
EG and GF
argument.
are not straight lines. I think that is something which we have drawn as straight line, right? I mean, why would we have a doubt about whether EGF is a straight line?
Yeah, EF is a straight line. Whether it passes through G is what we need to determine. But we said that to determine that, one of the ways to see is if EGF are collinear. Right? And by if it's collinear, it's not a triangle. If it's not collinear, it will make a triangle. So I think, Ashwin, that's what you were saying.
Okay, got it.
So, yeah, I think one other way to think of this is, instead of thinking EF is a straight line and asking whether G is part of that straight line, I would rather define as, okay, now I have an intersection point G, which is intersection of these two diagonals. And then from E I join to G, and then from G I join to F. Now asking whether this whole thing is so you can think that way.
Okay, got it.
So for now, for us, E and F are just midpoints. We are just connecting G to the midpoints. We are not yet, we want to now establish that EF is a straight line. EGF is a straight
Or can we prove the converse of, like, can we say that, okay, like you can see what I've drawn here?
line.
Is it here?
Uh,
Okay, so we will see how it will be like possible to prove that it is not concurrent, and then we will come to a point where we cannot prove that. So obviously it is going to be concurrent. We come the other way around.
Saying like proof by contradiction.
Another thought process with respect to the proportionality itself. If we draw a line parallel to the two parallel lines through the trapezium, that will cut the non-parallel sides in the same proportion, right?
So yeah, I was thinking of the same thing.
Okay, then what is the ma'am, can you repeat, like what was the claim?
I was just thinking aloud. I mean, if there is a parallel line, that any parallel line for that matter, when it is passing any line which is parallel to both the parallel sides, passing through the trapezium will cut any line in the same proportion as the non-parallel sides.
Yes.
Correct.
Will cut any line.
So basically, A P1 by P1D will be the same as B P2 by P2C.
By P2, and any line which is non-parallel will be cut in the same proportion.
Nice.
Yeah, so this should also be the same as okay, so yeah, right now we are just taking G to be the intersection of the diagonals. From this, I think we can prove the statements that Soumya made, that is the congruence of the triangles.
Similarity.
Sorry, similarity, yes. Oh, by the way, I also think G will be the midpoint of P1, P2.
Yes.
So, okay. Did you also have this claim of the meeting point to be the ratio of the top and bottom? Meeting point on the middle line.
You mean this here?
I didn't make that claim, but I think this is true.
What is BG? BG AG by CG, AG by CG. So there is another, I think this is something we were working on. I don't know whether you remember Gauri and Nagesh, where we had also one more thing, which is this might also be equal to AB by DC. So many.
Lot of question marks.
I took a different angle. I went for this thing of trying to prove EGF is 180 degree.
Okay.
So I think it can be done, or at least.
Okay, I will write here so that the diagram still.
But proving EGF is 180 degree, how it will prove that even diagonals are meeting at that point?
So,
okay, so
G is already defined as the point where the diagonal. Yeah, Nagesh.
Yeah. So I did not consider, like I did not join EF like that. So E is the midpoint of AB, and then F is the midpoint of DC.
Okay.
And then from G I have joined E and GE and GF. So I'm not assuming that EGF is a straight line.
Okay. We have the diagonal.
We have
We
the
have
diagonal.
midpoint.
G.
We have the midpoint E and we have the midpoint F.
Yes.
So we've joined it. Okay.
Yes. So, so the thing that I went for was EGF total angle will be same. Okay, so before that, okay, let's the bigger idea was I kind of wanted to show EGF is same as, okay, how do I put it? EGF the other side. I mean the reflect.
FGE, I will write.
Yes. See, EGF is EGF.
Okay. Yeah. So basically you want to show that this and this will be same.
Yes.
Nice.
This is what I wanted to go for. So first thing to see was like AGD and BGC are like opposite angles and they'll be equal.
AGD and BGC. Okay. So these two will be equal. Okay.
Yes. Now, since F is the midpoint, DF will be same as FC.
DF.
Same as FC.
FC. Okay.
So it will also basically bisect the angle DGC.
DGC.
Yes.
Why?
How do we know that?
So if I have a random triangle,
yes, if
you're saying if you take the midpoint and join it to the apex, it's going to bisect the angle.
Yes. Okay. Okay. Why do I say that is?
No, why? Let's take a very weird case where it might not be true.
Basically, you can just take a right triangle where one of the legs is 1, the other leg is 2.
Okay.
Yeah, that's just 90 degrees. So clearly, this part will be 45, and the other part will that part
definitely cannot be 45. Like, so this cannot. This has to be less than 45. So for the proportionality thing, so if we just take diagonals are straight lines. So we already know that A, B, C, D, and this we've taken as G. So by parallel line properties and this opposite angle properties, we can say this much. So we have two similar triangles, and from there we can show the proportion.
So I was just using the property that if I have like 3 parallel lines, anything I draw inside it will split proportionally. So I'm just imagining all possible parallel lines that are fitting in between AD and BC, and that EF will pass through the midpoints of all those. Wow. And if you extend that triangle up, it will be true for the whole that triangle as well.
Yeah, I'm also thinking of the same thing.
If G is the midpoint of P1, P2, if we prove that, we are done, right?
So how?
So EF passes through the midpoints of all the lines parallel to DC. All the line segments parallel to DC and having endpoints on the sides AD and BC. Okay. Now P1, P2 is one such line passing through G, where G is the meeting point of two diagonals. So if we can prove that, I mean, if we construct the line P1, P2 at G, passing through G, that is parallel to DC, and we show that P1G equal to P2G, that means it's the midpoint, and so EF must pass through it.
So if G happens to be the midpoint of P1 line P1, P2, then EF should pass through it.
Okay. Interesting.
Yeah.
Uh,
So I'm just thinking out loud. Just hear me out. So we can show that AEGP1 is similar to AEFD.
You have not yet shown that EGF is a straight line.
Yeah,
Either
but
to assume EGF is a straight line and to later show that F is the midpoint, or if
E-
you are getting E and F as the midpoint, we have not yet established EGF is a straight line yet.
but that is not coming here, no? He's just looking at two EG, the line EG and the line EGF need not be the same lines.
Oh, okay.
He's just
So he is just claiming that the two trapezium, they are both similar.
yes.
Okay.
But that would be true for any line which is non-parallel to the two parallel lines. I mean, any line that is passing through the two parallel lines. This particular thing, it need not be the midpoint of AB and DC.
Yes, now we have not established. I'm just saying that these two are similar, but we are not claiming that G happens to be the midpoint. So we need to still prove that. So all I'm saying is this, like the two quadrilaterals are similar. So and another thing is the all the sides proportion. I can take that proportionality constant as okay. I can now, if I say that if we can we can show that they are similar. Basically, they're all parallel lines. Now I can also say that EG by EF, EG by EF will be same as PG by DF.
P1G by
PG by DF. P1G by DF.
Yes.
Okay. And the
Similar.
same thing would hold on the other side, right?
Yes.
So, which is also equal to
Thing equal to
P2
P2G by FC.
FC.
Now
So
DF is
DF by FC is equal to P2G by P1G.
yes.
This we know to be in the ratio. I mean, they're equal, so that's one. So these
Yes.
will also be equal.
Yes.
Nice.
Hmm.
So it's the midpoint, and hence it will be on here.
Okay, below the proof line, I have assumed that, okay, that trapezium, the points are not concurrent. Like I'm taking it not to be concurrent.
Right.
And then I have to now, we know when the diagonals bisect, we know AG by GC will be equal to BG by GD. So now point P, which is formed by intersecting AC and EF, is the point P. So now that point P I'll take and I'll write, okay, AP by PC.
One second. Let me get my diagram, new diagram in order. Okay. So you've assumed, okay, this is the midpoint G. It's not passing through G. Let's see what happens. Okay, then. Okay, next you have said AP by PC is equal to BG by GD.
How did you?
Oh, now I don't know how I took this.
AP by PC equals.
I don't know how I took this.
These will be
What
from
went
two
in my head
different
that
parallel
time now?
lines.
Yes,
Right.
So
Right.
Yes, in your argument also, how did you prove the trapezium similar?
So there we had that P1G is
Angles.
equal to AB and BC.
Oh, 4 angles of a. Acha, 4 angles and parallel lines. That together will prove similarity of trapezium. Okay, sorry.
4 angles are same. Does that mean they should be similar?
4 angles are same and 2 are parallel. 2 lines are parallel.
Yeah, even then.
Wait, so what is the similarity for quadrilaterals?
All 4 angles are same and all 3 angles are same and 4
all
sides are
four
same.
sides-
No, but
all four
actually,
sides
it's
are
trapezium
that
is a part of
congruency.
a trapezium is part of a triangle. So, according to what Nagesh sir said, they are similar because when we extend both the triangles, they become a triangle.
I think we
Right.
can look at it that way.
Mm.
Extend the line, it will become a triangle, and then I can say that the 2 triangles are similar.
For a general quadrilateral, similarity.
Yeah, I was actually thinking for a general quadrilateral, if all the angles are same, can I say that the quadrilaterals are similar?
Square and rectangle.
Yeah. Okay, yeah, we have.
Should be all angles are same and corresponding sides are proportional. That everything has to match.
Hey, wait. How are they similar? I have a big.
I'm also not. I'm just putting this out.
You're
So
talking
in
about
similarity, it should be a zoomed in version. So if one of the sides is same,
Yeah, so I also agree with Nagesh's claim that AEGP1 is similar to AGFD.
let's say one of the sides is same. How can it be equivalent to zooming in? So for a similar things, like one definition we can go for is by zooming in or out, we should be, or like by rotation and zooming, I should be able to get back exactly the same thing. So here one side is same and one side is big.
One side is same, one side is big.
So if I zoom, it will go. No.
No. So, I mean, so it is the same as in the triangle case, right? So, I mean, just imagine that you have a triangle and you draw a parallel line cutting like parallel to the third base, like the third side.
So there all the sides are changing.
yeah.
No.
Yeah.
Okay. Yeah.
Right.
E is the same side common.
A is common. But I feel that even though the similarity argument does not hold, I feel the proportional argument holds.
Argument holds.
I have an idea. Can we draw as I say? I mean, let's have is possible to get a new fresh figure?
Fresh picture?
Yeah.
Yes, our own picture.
Yeah, that should be fine. I mean,
I've just drawn one, no? Yes, we'll use this.
Yes. Okay, so in that fresh picture, we just have one diagonal and one line which is meeting both the midpoints.
Okay, so one diagonal.
And the other line is meeting both the midpoints.
All right, got it. Hold on. Okay, there we go.
Okay, now the EF is the line which meets both the midpoints.
Correct.
Okay, now if we are proving triangle, can we have a name, maybe G, in the place where they are intersecting?
Yes.
Now, can we prove that AGE is similar to CGF? AGE is similar to CGF?
CGF.
Yeah.
They are. Now, another picture.
With the
other diagonal and this midpoint line which is meeting the point. Again, we prove those two triangles are similar. We also know that the two triangles, that is AGB and DGC, are similar. That we have already established. When we add both of them, we are able to establish that the entire triangles are.
So one small thing is, we don't know whether DBC will pass through G. G is defined as the point of intersection of AC and EF, right?
AC and EF.
But we don't know whether BDC will pass through G. That BD will pass through G.
So the proof for this, without looking at it as similar trapezium, by just extending this and forming this triangle and consider this point as some H. That way we just have to deal with triangle similarity. That way also we can prove this.
No,
Yeah.
but question is
EF, EG, GF thing is slightly harder, no?
yeah. So
Sorry? No. So if I okay, sorry, not this one. Okay, I'll take this. Extend these two.
now the question is, will EF, will both all these three lines, will it meet? Now that we don't know.
What?
Now the question is, FHEG, is that a straight line? In the sense, if I EG, FE, will it touch H? That we don't know.
So
But
forget about E. E and F are not midpoints. They're just the points at which this line intersects AB and CD. So EF are only the points at which the line H, or the line that connects HG meets AB at E and CD at F. Okay. So now, because of parallelism, we have so many similar triangles. So this triangle is similar to this triangle, but also this right angle triangle, not right angle, it could be anything, but this smaller triangle will be similar to this triangle. And this will be similar to this. So those proportions are maintained. Oh, but I only proved that they're proportional and not.
No, but then we have DF is equal to FC.
DF is equal to FC. I didn't start with that, no. I said it's just a point where the line HG meets CD.
Oh, then we are not yet.
Should we wrap for today and continue next week?
Yeah, I guess.
Wrap for today.